And as Simon saying, my name is Wagner Silveria. I'm a senior product manager with Microsoft working for the Logic Apps team. Right, I relatively close to you guys compared to some of the other PMs because I'm based in Auckland, New Zealand. So I think we are 5 hours ahead or 3 hours ahead. I think it's 5 hours ahead from. No, you guys are at Adelaide, right? So 3 hours ahead probably.
Yeah, we're plus 9:30.
Okay, yeah, and we are plus the 12, so 2.5. Let's split the difference.
Yeah.
Yeah, and what we're going to be talking today, I think, is that it seems to be a new topic for for this audience. Going to be talking about Logic Apps, but focusing on the local developer experience. Since the last year, we've been doing a lot of work on trying to improve the getting started and the day one and day 10 on Logic Apps, right? And for that, we started to map some of the things that customers or developers used to do and see how we can tackle those problems inside VS Code, inside our, specifically inside our extension. So let's think about like common developer activities for Logic Apps standard, but it doesn't matter what kind of developer you are, you're going to recognize some of those, right? You needed to onboard, like you needed to get new environments or set up a new environment, set up a new projects. You needed to pull code from repos, and on that, VS Code is really good because it already brings like a lot of that integration. But you wanted to make sure that when you get to VS Code and you set up your environment to use, it doesn't take like a lot of manual steps. Otherwise, you're going to spend more time setting up the environment than actually using it. Then after that, you go to create projects, create workflows. You wanted to sometimes extend your code or your logic with external components, with other extra components that you don't have in the tool as well. You wanted to test workflows, right? Then you wanted to pack that project for deployment. Wanted to make sure that you abstract those components and you're preparing deployment scripts, you're preparing the pipelines, but also pushing that to other environments, deploying, verify that the deployments are okay, and most important, deploy mission critical applications without downtime. So we look at that set and try to find the things that we should be working to make sure that most of the things, if not all of the things that we have in that list, could be solved, and you have a way to do that using the tooling that we provide, right? So if you flip that, from an onboarding point of view, we needed to make sure that the setting up that environment is easy, that you wouldn't be having to go and do a lot of the manual installation of frameworks, of components, and things like that. But also, as our tool evolves, if you have new versions or you have different dependencies, that could be bring to you straight away without you having a lot of work, right? From a development point of view, we wanted to allow you to extend your code in any way that you want, to extend your workflow in any way that you want, right? And you've seen that I calling workflow and code in like interchangeably here, because from us, the declarative workflow JSON, the workflow definition is code for us, but that can be combined, for example, with C#, either inside workflow itself or as a component that I can bring. And when you have in that code ready and you wanted to make sure that it's in the quality that you want before you push it to source control, before you starting to push to other environments, that you can automate the testing for that for those workflows. From a packaging point of view, we wanted to make sure two things. One is that since we're dealing with a mix of code and configuration, right? And we are going to show what we're talking about this when I open my Logic apps and discuss a little bit of that. That anything that we abstracted when you push into other environments that are related to those configurations or those Azure resources that we needed to configure are parameterized from the ground up. It's not an afterthought that you have to go and do a whole manual set of changes, and because of that, you're having trouble having to test again. And whenever possible, be able to auto-generate deployment scripts and deployment pipelines. Finally, from a deployment point of view, once you have those pipelines in place, for those mission-critical applications where you needed to deploy applications without having any kind of downtime, being able to support those zero downtime deployment scenarios using technologies that are already available in Azure without trying to reinvent the wheel, like in this case, using application slots, right? So I have a laundry list of items here that we've been working, and this is being done since last year. But because of it was the first time for most of you, I make sure that I bring like more of that ALM, right? That application lifecycle management. And in some cases are going to have just a pre-recorded demo, but when getting to unit tests, for example, because it's the latest and greatest on that, less people might have seen this, then I'll do like a live demo so we can spend a little bit more time on automated tests, right? Show of hands or just thumbs up on the on the teams if you guys are okay with that approach.
Yeah, that'll be fine, Wagner. Thank you.
Great. So let's continue. So let's start talking about the simplify onboarding for developers, right? We did a number of things, and all of that is now on GA. So now if you go on a blank machine and you needed to install Azure Logic Apps, it's going to find all the dependent all the dependent extensions and install that to you automatically. So empty VS Code on a new dev box, you select Logic Apps, it automatically tracks those dependencies, install all of that to you. But more than that, when you're installing, and every time that we start in a new project, we take a look if our core frameworks, the frameworks that we use to make sure that the Logic Apps works, are installed. And because we know that some people is not going to be using, like, to be honest, most of the people is not going to be using that machine just for Logic Apps development. And we have very specific set of requirements in terms of versions of Node, versions of functions core tool, .NET, etc. We decided to go with an approach where we set a portable folder, right? That in this case is say users my user.azure logic apps, and then inside that we install all the dependencies. So in that screenshot here, you're seeing that I'm installing the version of that Node.js that I need, the version of functions core tools that I need, the versions of .NET SDK that I need, and that becomes transparent to you, right? If you, on top of that, you needed to use .NET 9, .NET 10, you should be still okay to install with no clashes, because that actually goes to your system path, where we're going to be taking dependency on that portable binary folder. If you wanted to get this in a place where for every developer is the same, that is fully configurable. So you can go and just change the settings to, for example, my cdev Logic Apps dependencies, and then every developer is going to have that installed there, right? That makes your life easier as well. The other feedback that we got from customers in the beginning was you would be starting the work, the extension, and then the only thing that you're doing when we starting the extension was going to get a list of my list of files, but we have some background processes that we needed to execute that the designers, because we're running with a local designer on top of that, needed to happen. And this before was kind of a lazy load. So only when you go and right click, open designer, that the designer would start to load. If the designer, for example, found there was a new version of my package, the bundles, like the Azure bundles that needs to be downloaded, that would also do that during that process. So the experience between open a project and starting to actually use the project could be relatively long, and 2 minutes in a developer's life is a lot, right? So we did a couple of things on that faster startup time. We associated some processes to as soon as the extension starts. For example, we now downloading our latest version of the bundle when our extension starts. We verifying all those dependencies when our extension starts, right? And as soon as you open a project and say, I open my VS Code, but I actually going to use Logic Apps, then we started to do our design time straight away. The same thing is when we go and start debugging this, similar to functions, we have a dependency on Azure, but before, the only thing we would do is like make sure that Azure is open. And I can remember how many times before we make those changes, I click on F5, I receive that message, I stop, I go start Azure, and then after that I would be running my debug. Since the extension knows that every time that I hit F5, I need that, we just automated that process. So it takes a lot of those small paper cuts for you be able to actually concentrate on the code, on developing the logic apps, instead of everything that needs to be done around the logistics to get it running. Finally, the last thing that we did, which is to help with a whole lot of other initiatives that we have, is making sure that the logic app applications are actually looking like solutions, right? And the closest to a solution that VS Code give you is the workspaces. And when I talk solutions here, I'm talking about disparate type of components, not all just .NET components, right? So the reason for those workspaces is with the workspace, you'll be able to host multiple logic apps, multiple custom code if you wanted to, inside the same workspace. So it started more and more and look like a solution. But most important, when we started to auto-generate code, that is some of these things that we're going to start talking really soon, like some of the other components, we're going to keep those pieces of components on their own folders, right? All tied together by the workspace file. So if I have to go and create a test project, I don't need to create a test project inside which is the example that I have here, right? So if I needed to go and create a test project, I don't need to create a test project inside the Logic Apps project. I have my dedicated a folder for that. When I create in deployments, I'm going to have my own folder for deployments. When I create a custom code, I'm going to have my own folder for that. And next time that I open my Logic Apps workspace, all of that is going to be rehydrated in the right places. That also is going to help you to push that structure to source control and push the whole set that makes the Logic Apps application to source control and back. So next thing that we have here is like how are we going to manage code, right? So we have two components that we created, and they work in different aspects, like in different aspects of your workflow. We have the custom code extensibility, right? And that custom code extensibility, we have two flavors of that. We have one version that was created using .NET Framework as a project. So it's basically a functions that is wrapping the .NET Framework component or components, and probably would be asking like, who in the name of all that is sacred want to use .NET Framework on today? The reason for that is historically Logic Apps is and not just historically, but from a Microsoft point of view, Logic Apps is the target technology if you're migrating from on-premises, integration on-premises, most specifically Beanstalk. And there was a lot of Beanstalk components or pieces of code that were created using .NET Framework, right? So back in 2023, we GA the custom code. Then initially with extensibility, initially for .NET Framework. And .NET 8 support, this is like an old slide, is in public preview since June 2024. It's actually .NET Framework was GA around 23, and we have a public preview for .NET 8 support since 2024. We're going to be GA that around June timeframe on our big conference that is called Integrate. And what is this? What is this custom code? The idea of custom code is that you are able to go and write a function inside VS Code with a specific type of binding that function, once compiled, can be presented on a Logic App workflow like an action. So it's a way for you to create your custom actions in a way, right? And with that, you can extend this to anything that you don't have an actual action available in Logic Apps, or when you needed to insert your own business logic to those workflows, but you wanted to make sure that your developers continue using that format, continue using like the normal workflow low code when developing that. Any questions on this one?
No, I think we're good so far.
Okay, so the next piece of extensibility is, if this is too much for you and you really just need like a small set of lines of code, or you already have your sample in C#, JavaScript, or PowerShell, which are the things that we are supporting today, right? We have a way for you to actually inline that code directly into the workflow. So the way that we usually see this is we talk about, if you have like a really small piece of a functionality that is specific to that workflow, you go and just use an inline C#. Then if you have something that is a bit more complex, that means that you need to test it in isolation, or that is going to be reusing across a whole application. That's when you're using custom code. And if you needed something that goes across applications and you needed to scale that independently, that's where you like use Azure Functions in conjunction with Logic Apps. That is something that was available since its inception. right? But before, people always thought about just Azure Functions as the way to extend, and now we have like multiple other ways to extend logic apps. And on that one, we actually have a little demo that I'm going to be playing now. And on that demo, we started with the HTTP request, right? And where we have some content and a file name, and we wanted to create a zip, like a compressed that to send to a bulk storage. So we're going to be using the execute C#, right? Then that C#, you can see that is like a workflow, and I'm going to be calling that compressed file. And after that, I'm going to be just inserting some code here that basically uses like the a zipping component available in .NET to do that, like using system.io compression. And then the result of that, I can simply send it to my blob storage, right? So quite a simple and common thing, but not something that we would be able to do it today without extensibility. Now we have like a really easy way to extend that. So seeing that one in action, we're going to be passing the file with like a file content and a file name. And when you finish running that, we can see that succeeded, but most important, when you go to the folder, now we have that zip file ready for us to be downloaded, right? So we are working on a repository with a whole lot of those small utilities that you can simply go and pick up those inline codes or those custom codes. And I'm going to be talk later on how can you also contribute for that. Cool. So we create workflow. We potentially extended that with some of those components. I now have a list of workflows that I needed to test, right? So that I needed to make sure that it's working. And testing on Logic Apps up to now, it was quite a manual process because you needed to start the workflow. You needed to make sure that all the dependent systems had data in the right places. That means that and depending on the type of the workflow, it was either a manual trigger or something that was waiting for you to trigger an event for it to start. And after that, for you to verify that the logic that you wrote was correct, you would have to go and look into manually look at that history to make sure that it worked fine. So we thought that was like quite a manual process, and that wouldn't give like the level of quality, but also the level of productivity that developers would need. So we came up with an alternative that actually is now our prescribed solution for unit testing or automating testing. But the first thing that you needed to discuss here is what is a logic app unit testing in this case, right? When you're talking about logic app unit testing for logic app, we're not talking about testing the smaller part of a component, which is usually what we'll be doing with unit tests. We're talking about testing a workflow scenario, because the only thing that makes sense for a logic apps to test is if your workflow has like multiple branches or multiple variations depending on the data that you pass, how can I automate that to test all those different paths or different data combinations, removing as much as possible all the external dependencies, right? So not being dependent of all those external systems, be one connected to having the data that you need in order for you to test. So The idea is decouple workflow logic, which is like usually the process that you do inside of workflow to get that business process to work. For example, decided when a message arrives is insert on an update, and depending on that, call a different API to insert the message or to update, and then remove that message from the service bus queue, right? How do I test all those different scenarios on that workflow without having to go and connect to service bus, connecting to those external APIs? The other thing is we wanted to improve that repeatability. So as you make changes in the workflow, as your workflow still looks the same and the outputs is still the same, those tests should pass, otherwise it shouldn't be failed. And you should be able to repeat that list of tests at the click of a button, right? With that, we wanted to people to increase code quality both locally, but because those tests can be repeatable and are automated, also be running that during a build process to guarantee quality locally, but also guarantee quality when multiple people push to the same repo. Then the approach that we get for that is we wanted to give you something that you don't have to learn again in order to use the testing. So we went up with creating those unit tests using MS test and mock, right? And for people that is new to that area, automate the creation of those code samples and scaffold unit tests as much as possible. So you only needed to really concentrate, depending on your level of expertise, on how you assert things. So the way that this works is something like that. And after that, again, actually going to show that live, right? So we have the inside of our extension, we included a couple of more components. We included what we call in that unit test generation wizard that, depending where you are on the UI, allow you to go and create that scaffolding code for a unit test workflow, either from a run that you already debug, like similar to that example that we showed before with the zip. If I already have that run completed and I wanted to automate that test to guarantee, instead of having to go to the zip location, see the zip is there, and see if the zip was compressed the way that I wanted, I could actually create a unit test directly from that execution, and then just abstract the bits that are connecting externally, test the bits that are just internal for the logic apps, right? But on top of that, we also create a logic apps unit test SDK that allow you to create those mocks, creating the sessions using MS test, execute workflows programmatically inside your code. And all of that based on MS test as unit test, the unit test framework that you choose. But because that's as an SDK, if you wanted to use another framework, you would be able to plug that, but you will be doing some work manually. The scaffolding is done using MS test, as other applications would do. Select one framework and stick to that one. Then the result of those unit test generation is a combination of things. The first one is you're going to actually have a solution with a project for the logic app, with folders for each one of the workflows, and inside that, C# files, right, with the test classes, the test methods, and a way to dynamically execute workflows if you need to, but also mock definitions if you decided to generate that from a run. So you having that that JSON file that you can go and manipulate it if you want to, or you can create all of that programmatically. From an execution point of view, we are actually reusing our runtime core components, but invoking that as part of the C# execution and exposing what we call in a workflow execution API that you can call from your test methods to go run the workflow, but because they know that are in test mode, every time that they find an action that would go outside of the logic app and come back, it injects the mocks that you created, right? The result of that is it's the representation of everything that happened with the logic app, right? If it succeeded or not, how each one of the actions actually being executed. And from there, you can go and do some assertions. The way that you visualize all of that is using the same tools that you already have in VS Code and with the C# Dev Kit, there is the Test Explorer. From there, you can see like all the tests, like view, execute, debug one or more tests, and see how the results did. So for that, let's take a quick demo on that one. I know that we already 43 minutes past, right? And so I'll try to go up to 15 after that, no more than this. So let me come here, and maybe the first thing, even before we get one of those projects, let's actually take a look at what the logic app looks like, because maybe some of the people here didn't even see that logic app before, right? So I'll try to open the designer. Come on. There we go. Just my machine being slow. So this is what the logic app looks like, right? A set of the actions. That's what like a trigger, something that starts the workflow, and a set of actions. In my case, when I receive a message from Service Bus, I initialize, I do some passing on the message that came from Service Bus with a schema. Then if my status is new, I set a variable to a target URL, my insert target URL. So I decouple that from the workflow. If I go to other environments, I just change that parameter. And then the result of that, I go and call a external API, right? With that target and the body of the message. If everything goes fine, I go and complete my message. If anything goes and get an error, I just abandon that, and that's everything that I needed to do on that logic app. So there is two ways to create unit tests, right? I can go and create a unit test directly from here, but before I do that, I actually show that like the way that most people that is wanted to get a logic apps running, sorry, a unit test running super fast would do. So I'll start that project. So it's building, is starting the function core tools, and I have here three. If I come back here, I have three workflows. I have two workflows that are responding to manual requests, right, when an HTTP is received, and one that has the service bus trigger, that is this one. The other two was like relatively easy to do because you could do a request against that and then take a look. But this one, you needed to go out, go to service bus, put a message there, then come back, see if things worked, right? And that's what I did for a while. So let me open it here. Like I did it for a while, and when I was debugging, then I have this one that I'm happy with, right? So on this, I actually have the execution, and on every step, that's one of the things that Logic Apps gives to you. It gives you the actual outputs of the messages, right? It says, I get this output from this action, I set up my variable, I parse your JSON, I did the condition. Inside the condition, because it was true, I set a variable to insert, right? Since my message was my message was new. Then I call your external API and I complete the message. Now I want a way to run this out like automatically without having to go and put things on Service Bus again or complete things from Service Bus if they don't exist. And that's where that unit test comes in place. I'm going to be creating a unit test from this run, right? And I'll call that test create from run. And what it did here is actually, I'm just going to open the solution. What it did here, it actually created a actual test solution, right? Like a proper C# solution. And on that solution, I have a folder and a project associated to this Logic App project. Inside that, I have a folder for my workflow, and inside that workflow, I have a list of tests, like for each one of the tests that I created through the UX, I have a folder with a combination of the C# and the mock data. So let's explore that mock data to understand what it is. Let me close a lot of those things. Is the size of is the size of the font okay? You guys can see okay?
Yes.
Okay. So on that one, right, on this mock.json file, what we did here is we mocked the trigger, and you see that is exactly that same message that we created, but with all the properties that was available to it. But the other two things that it did is it created an action for my call external API and for my complete. First question that you guys might have is like, what is the other stuff? Any idea where the other stuff is? The other stuff is actually the stuff that I wanted to test, right? Because this, the mock, sorry, the call external API, the completing message, and the trigger are the dependencies that I had with external systems. Now I can come to here, define this mock the way that I really wanted to test the things, and then execute that test and see if it passes or fails. So the idea then is like on the test create from run, that was the C# file, it creates a C# class that initializes our test executor, right? And that test executor is basically a way to wrap the files that was doing that, because remember, we're still running that Logic App on the runtime, but injecting injecting those mocks at the right places in the code, right? Because of that, we still needed to know where my workflow JSON for that particular workflow is, where sample workflow 3 is, where are my connection JSONs, my parameters, etc. Then in this code, we provide 3 samples as an scaffolding. The first one is trying to show you how, for example, to change a particular property. So I give you like a hint here to how to change that property. But the most important part is how you execute the code and get the run available. So after that, we started to do assertions on that. Then we have another 2 examples. One of them is if you wanted to dynamically generate a mock, you have the ability to do this, and you show like how you could be doing this. And also what to do if you wanted to create an API with a failing error, right? So in this case here, like how that workflow would look like if I have an error. Like how do I mock an error so I can also test the negative path, right? Then a set of generated mocks. The other thing that we do, and this is like something for the next step, is when I created the mock outputs, I create a set of mock outputs, which are the actual class for the those actions, the action types, right? If I wanted to manually create abandon work code, how can I do that? We have a sample of a class here. If I wanted to create an output, an API manually or dynamically, I have the class here. So you don't need to know, for example, like let's get this when a message is available. I don't need to know all the parameters that my service bus required or that I can use on service bus because I have like a well-defined class here to use. Okay. So on interest of time, I'm going to generate another one of those. Just so you can see the create from designer. But then I will jump to another project where I actually have like a lot more advanced options, and I'll have those ones created in a much cleaner way. Because as I said, those are boilerplate code for you to go and understand how to use. But then from there, you most always not going to use it as is. You go to do some more assertions, maybe in adjust a property here, a property there, right? So I have some examples of that. As I said before, the 2 ways to do that, one was creating from that run. If you already wanted to have a mock pre-created for you to accelerate your tests, the other way to do is if you have cases where they are more complex, or you want a more control of how we're going to generate the data, right? Because you have too many scenarios and then you actually wanted to create that dynamically. That's where create unit test from the workflow definition comes in place. So on that one, test create from definition. The main difference from that is that it's still going to create the workflow, but one is not going to create a mock.json, right? So from here, you are ready to go and start creating your code manually. So if you don't need that mock.json, you don't need to create that and then delete and then do other stuff. You can create directly from the definition, and then from that, you started to create exactly what you want. We still create something similar, right? Like a sample for success, a sample for external API on those cases. And yeah, we just don't create a sample for the failure here, but creating all those other ones. And let me go to another project. And I not go through all of those examples because I'll just just for interest of time. But let's go to, in theory, that simple one, right? So the create from run, where I have this initial set. And for me, the variations of that are really simple ways. I have a message in status of new, or I have a message on status of the updated. And what I wanted to test is, if it's new, is my variable actually pointing to the new endpoint? If it's update is pointing to the updated endpoint? If it fail, I'm actually abandoning the message, right? So here is exactly the three workflows that we had. I created the first one was pretty much as is, but then on top of the two assertions that I had, I can do something like this, right? You saw on my code that I was doing my test variable is actually assigned to insert target URL. Is that still valid? Is still it is still working? Let's see if it's correct. And then later on we can go and do another change in the workflow and see if the workflow fails. Then on my second one, now that I only needed to change from I needed to change from new to update, I can actually go, I can actually go and just change the mock data to update. Let me increase that a little bit more. There we go. I think that is better for you guys to see, right? So instead of recreating the whole mock data for that trigger, I just changing my status under the content data, under the body, to update. And then now I test if my, Now I test if my variable is assigned against is the same value as an update target URL. And the last example is now I creating that a mock API. I creating that action mock API, but now as a failure, right? Actually doing a little bit of different here. I call in a dynamic callback, and that dynamic callback is actually setting that as error, just to show that I can also using that dynamically. And what I expect now is that my test workflow fails because it failed. The result of that would be a failure, right? So I can go and get those workflows, right? I can get everything that is under create from run and test and see if they passes, right? Unless they did any changes, they should pass. Right, so it's still passing, but just to prove that I actually doing that and what we're doing, what you have available for that. In this case, I going to run this one here, and I'm going to debug that test, and I'll put a breakpoint here and a breakpoint here. Right, so I can debug the test. And then I hit my test run. When I finishing running the test run, I have access to to all the results, like all the actions that were available, right? I have 6 actions, like for each one of them, the abandon, the call, the complete message, like everything. So I should be able to do sessions against any one of those. But on top of that, on my workflow settings, I also have access to parameters, right? And here is like an example for a parameter, but also for app settings and other things. right? So now I can go, is the test run is now? Not, because we saw it before. The workflow status was succeeded, yes. And those two values, the test run variable and update target, was correct, yes. So then the test passes, right? So you have a lot of ability here to fully decouple this from your other environments. Let's go back to the session. Any questions on the unit test framework, either from here or from the audience online?
None from in the room, it seems.
Cool. Clear as mud?
Yeah, very
Hopefully not clear as mud, but clear as water.
Yeah.
All right. So just to complete, like now, I wanted to spend a little bit more time on unit tests because that one is new. Like, right, there is a lot of people that is not that didn't see that before. Like one, the other ones is a little bit in the wild for a while. But continue. Sorry, before I forget that, if you wanted to know more about the framework, you should be able to find a blog, which is aka.ms/LA standard, logic apps standard /unit test/blog. We have the QR code here if people wanted to screenshot or use the phone. And inside that, you're going to have a link for the documentation, an expanded version of that the demo, right? Where I went through all the different scenarios that I had there, including dynamic calls, dynamic calls with loops. So we have a whole lot of examples, and also the link to a repo where I have some of that code sample that you can look at and to learn a little bit more how to use it. Then now that we create the unit tests, or create the code, we're happy with the unit tests, probably the next step for that is generate deployment script, right? Parameterize, getting that all ready to deploy. And for that, we did some work on the VS Code extension as well. The first thing that we're doing is, if you don't have a prescribed way to parameterize, because some people was already using logic apps before we came with some of those guidance, right? So if you don't have a prescribed way already inside of your organization and wanted to adopt the way that we are guiding you to use the parameterization, we are now parameterizing your connections from the start. You can opt into that, right? If you don't parameterize, the only thing that is going to happen is we'll not be able to generate those scripts that we're talking here, because that's we took an opinionated approach for that. But if you're already doing that parameterization, chances are that you already have your own auto-generation scripts, that you already have your library of things that you're using to create that for logic apps. So you can continue using that. We didn't want it to impact other people's processes, because we came with that after some consideration. All right. So what you're going to see here is those connections are going to be parameterizing from the start. And I can show what that means in a minute. The other thing is we are also be able to, with a right click, generate scripts, and the scripts are going to generate a couple of things. It's going to generate that infrastructure script. So all the connectors, that might needed templates, all the logic apps application with the dependencies. It's also going to create pipelines to run that infrastructure, to do the CI and to do the CD, and going to be getting your configuration files and creating a copy of that, so you can actually reuse that in other places and make and change the configuration files without impacting your project. Today, we are supporting ARM templates and Azure DevOps, right? And we have some questions around that. Azure DevOps, because the majority of our customers today, based on a lot of research that we did, is on Azure DevOps. ARM templates, although it's an older technology, is the common denominator between all of them. If you have the ARM templates and you actually needed to generate a bicep, you're able to easily generate from that, right? And potentially you could do something similar. You could actually use those ARM templates and create Terraform scripts that run those templates. So with that, we created in a way that, like in theory, everyone could use, but we are looking for feedback on what is the other deployment of the script languages that we'll be concentrating next, right? We got a lot of feedback from Bicep because it's something that most of the Microsoft focus the teams are using. When I say Microsoft focus teams, not the teams inside Microsoft, but people that concentrate on Microsoft technologies, and people that is doing more generic stuff is actually focusing on Terraform. So we needed Signal again to make sure that we're using the one that is the most important, right? And I have another demo here, so I'm going to run this one quickly, just only for interest of time. So you have on this we have a service bus connection, and on that connection you're going to see a couple of things. You're seeing that inside the workflow we already parameterized things like the location, the resource group, and the subscription ID. Those were things that would be coming outside that was hard coded before, and you would have to change that as part of deployment. The other thing is like removing some of the components like runtime URL and authentication that change between local and development, and also parameterizing all of that, right? So with that in mind, when you needed to generate a deployment, you can go to, and as I showed here, just right click and generate deployment scripts. Then you can pre-select a set of steps, right? In my case, we're going to be creating, I'm creating a new resource group on an existing subscription, and select what is those locations are going to be, what is going to be the logic app's name, what is going to be the storage account, what is going to be the app service plan. So when you're doing that, we're not hard coding those values. We're actually getting seeds for the values. So if you try to run the ARM templates by itself, you already have a set of parameter files with those values embedded, right? So you can actually take those ARM templates and run yourself, not just using on our pipelines. But our pipelines actually allow you to apply environment variables on that. The types of pipelines that I said that we created is we have the infrastructure template in this case, right? And that is the one that actually creates the logic app itself with the set of parameters.
Your screen's no longer shared, Wagner. I think someone accidentally kicked you off.
Oh, just a minute. There is something. I think it stopped sharing.
Yeah, I think someone accidentally disconnected you.
Okay. How far did you guys miss that?
No, that's
just now.
It was about 1 minute ago.
Okay, so let's just come back here, and then so the next one is the parameters or the template for the service bus connection, right?
Yeah.
If you're using one of the Azure connections, and again, everything parameterized. We also parameterize the security, the components that are required, and all of that. Then Yeah, with all the parameters. So I think now we're going to be showing the pipelines that we created. And in here we have infrastructure pipeline that is going to be executing all of that. So you can plug in on your Azure DevOps. With all the parameters, we creating some tasks to simplify the process for you. Right, so we have now a Logic Apps build task. Which is this one. And after that, you publish the artifact, and then that can be used by the CD pipeline. And as I said before, like those parameters that you pass as part of the variable files that you can change for environment variables, right? This is the release task that does the same things. If you have app settings that are not the app settings that we drive, you can actually add your own, create your environment variables and things like that. So the idea with that, finally, both the user created and the system generating parameters, like out of that auto parameterization that we created. So the idea here is that with a click, you're able to create this, then adjust it as you need it, and plug in on your own Azure DevOps, right? Push that to source control, plug in on your Azure DevOps, and now you have a continuous integration, continuous deployment, delivery system in place. Last one is zero downtime deployment, right? And the idea is, if you're having applications that are mission critical, you're actually able to deploy them without having to stop the application, because we use the same kind of we're using the same kind of mechanisms that other applications, that app services and functions are using by creating a slot. The thing to take here in consideration here is, most important, the Logic Apps standard slot is read-only, right? So we created that just for zero downtime deployment. When you install the code, we run our validation task the same way that a new application would start, and you should be able to see if, when you swap the slots, your application is going to crash or not. But at this stage, we are not creating like A/B testing or blue-green deployments. And the reason for that is because most of the times when you're creating that kind of scenario, you're always working against reactive endpoints, right? With Logic Apps, like the example that I provided to you for unit testing, was actually the messages responding to a service bus. So if you're deploying that and you wanted to make sure that the code goes against production, against all the production endpoints, and without the application crashing, if I try to run some of those, I actually going to be splitting. All of a sudden, I would have a competing consumer between my staging and my code, right? So you have different pieces of the code trying to get triggers and trying to get data from the same systems. So we decided, as a first deployment, which was the first iteration of the deployment slots, to keep that as a read-only. Based on user feedback, then we can try to find solutions to how to implement this in a way that you can actually deal with different maybe different endpoints or doing that slicing of endpoints. A quick demo of that one, and I think that is the last demo. Then after that, I just have like a couple of quick slides to call to actions. But here we have an example where I have a Logic Apps workflow, sorry, a Logic Apps application where I have two workflows, right? And I creating a new deployment slot. This I did manually just to show the feature, but all of this can be actually automated. So I have a staging workflow, a staging slot. There is nothing deployed on that. Then now I go to Logic Apps and get in that Logic Apps project, and I'm going to be deploying against the application on that particular slot. And notice that I only show you the staging, like the non-production slots, right? So you know that you're deploying to a non-production slot. So it goes through the process, is deploying the code, then it's testing to make sure that the staging is correct. Deployment, it's okay. I uploading some extra settings that it might be required. I don't want it to upload anything that is overwriting, so I just said no to all. But it completed and completed called copy service bus, connectors and stuff. Now I have those two workflows on the staging. And I can actually look at that, but it's not, you can see that it's all read-only. I can still verify that the code has been deployed correctly and everything, right?
Wagner?
Yeah.
Wagner, hello?
Yes.
Sorry, we are running a bit short in time. We've only got about 5 minutes left, just to let you know.
Now that's like a 1 minute on that one.
Okay, thanks.
Yeah. So the only thing that is going to show here now is that you can actually swap, right? And that's it. So I can actually advance this a little bit to show that when it's swapped and you go to the staging, now I have the old code there. And if you go to production, I have the new code, right? So all of that is available. I think it's like just to conclude here, you can see that we made improvements from the Logic Apps development point of view on the whole ALM, right? From the onboarding all the way to deployment and making sure that we are taking care of critical applications. Just a couple of quick call to actions on that. If you wanted to know more about Logic Apps in general, right? We have what we call Logic Apps Aviators community. We do monthly calls, and you can find that either searching for Logic Apps Aviators hashtag on any one of the social media, and turn in on last Thursday of the month PST time, right, on Logic Apps aka.ms/Logic Apps Live, LA Live, and you can go to the blog that at aka.ms/AIS Tech Community. If you wanted to contribute, then we actually have a couple of things that you can do. You can go to and submit new articles for what we call in the Aviators Community Playbook, where you can actually go write your article about the patterns or how-tos or conceptual articles about Logic Apps, and we publishing that directly on MS Learn on the Azure community area of that. But we also created a new initiative that called Logic App Labs, and that Logic App Labs allow you to actually create new labs, right? And we have like a whole lot of different workshops here already, but it's just a matter of getting a copy, forking that GitHub repo, create your own archives and submit a PR. And with that, we're going to have new labs available. So with that, I think that's all that I had.